Hi there, I'm Sam.
I'm Jonathan.
This is BWY Chemistry. Today we're going to talk about a table.
Yeah, not that kind of regular table. Like we're doing chemistry here.
The periodic table.
Yeah.
Before getting started with the scientific study of the periodic table, let's discover a bit of its history and its evolution first. You may ask, even a table like this has a history. I'll tell you yes. And its evolution is about 300 years long. And even the table right now is not complete. And there might be more elements scattered around that we haven't noticed or discovered yet.
Right. So in the year of 1862, the first ever periodic table is made by
Bagayar de Chankordwa.
Which is pretty much like
this. Yeah. Ain't sophisticated enough, huh? Yeah, after 1 year, John Newlands has written a report about it and had classified 56 elements into 11 groups. So also like the loss of octaves is discovered 2 years after that. And we will cover this concept in this video. Yeah. So by the year of 1869, there were 60 elements being discovered, and Mendeleev had put them in correct order, and it began to look like a periodic table, which is pretty much this one. Yeah.
the contemporary periodic table now looks like this. So the layout of the periodic table is relatively precise. The horizontal rows are called periods, and they're numbered from 1 to 7. The elements in the same period have the same number of shells. Each period contains elements with electrons in the same outer shell.
So as mentioned in the atomic structure video, the electrons in the outer shell are called valence electrons. And the columns in periodic table are called groups. And each group has the same number of valence electrons, and they number from 1 to 18.
To conclude from the previous statement, columns are groups, and elements in the same group have the same number of valence electrons. Rows are periods, and the elements in the same period have valence electrons filling in the same shell.
How does the concept of valence electron work? And how do I figure out the number of valence electron in an element?
This is a very good question.
So as mentioned above, the number of valence electrons is pretty much counted from the first row to the last row. Yeah. And then unless you remember the whole periodic table, you need the help from periodic table. I mean, that's why it exists, right? Like the periodic table. The thing that you gotta remember is that the transition metals won't be taken into considerations when talking about valence electrons. That is because they have C of the electrons, yeah. And the first column is corresponding to the elements with 1 valence electron, yeah. And then the second column is referred to the elements with 2 valence electrons. And then after skipping the 10 columns of transition metals, the 13th column to the 18th column are corresponding to the elements with 3 valence electrons to the elements with 8 valence electrons. Yeah, that's pretty much it.
The way you draw graphs of each element is included in the video Atomic Structure, which I highly recommend you go and watch. You can go and check that out after finishing this video. Here is one regular element out of the 118 elements in the periodic table. It is carbon, and I believe everyone has heard of this word in our daily life. Yeah. Every creature and living thing needs carbon and is basically made out of carbon. And this is one of the basic elements that make up our body.
So this is a carbon block from the periodic table, and let's take a look at this. Firstly, the capitalized big C in the center represents the symbol of carbon, as we know. And it is a C. And the word below the big symbol is obviously the English name of this element, and the number below that is the atomic mass of the element. And its unit is atomic mass unit. And the atomic mass unit is a unit particularly for elements. One atomic mass unit is 1/12 of the mass of an atom of carbon-12. It is defined as by the authority. By the authority.
What does carbon-12 mean? What does the 12 exactly mean?
So this involves the concept of an isotope. Isotopes are different formations of the same element. They have the same number of protons and electrons, however, they have a different number of neutrons. Let's take carbon-12, for example. Carbon-12 has 6 protons, 6 neutrons, and 6 electrons. Carbon-13, however, has 6 protons and 7 neutrons and 6 electrons. All these are a few more types of carbon.
So if you're a 6th grader, you can pause to stop the video and review what you have learned by now and exit the video, since the later parts will be really challenging for you guys. But if you are really good at chemistry and interested in chemistry, you can continue the video, since the later parts will be useful during 8th grade and 9th grade study,
Okay, so there are 3 different categories of elements in total, which are metals, metalloids, and non-metals. Yes, most of you must have a clear understanding about metals, non-metals, but metalloids is rather confusing. You can understand that metalloids are substances that are between metals and non-metals. They have both property of metals and non-metals.
However, the above mentioned types are just the major types and can again be classified into 7 types. And the first type is called the alkali metal, and it includes lithium, sodium, potassium, rubidium, cesium, and francium. And alkali metals are less dense than the other metals. All alkali metals tend to lose 1 or more electrons to create a positively charged ion called cation. And the concept of compound will be introduced and explained in later video. So the alkali metals have only 1 valence electron, and the alkali metals are the most reactive ones of all metals. So adding them to water will cause the release of hydrogen and the formation of very strong bases. And alkali metals are highly reactive, with reactivity increasing moving down as you move down the group. Therefore, the reaction between water and francium will be explosive. Alkali earth metals are in the second column, or as you can say, like group. And they have 2 valence electrons. They will form cations also, just like alkali metals. And one of the key properties of alkali earth metal is that they become increasingly soluble with a decrease in temperature. So the third type is the transition metal, which are located at the middle part of the periodic table. And transition metals are far less reactive than alkali metals and alkali earth metals. They have 5 high, which are high densities, high melting points, high thermal conductivity, high electrical conductivity, and high boiling point. They can be used decoratively.
Metalloids and semi-metals are the 4th type of all elements. They may have a metallic luster, which means it may look as shiny as the metals. They have variable density, hardness, conductivity, and other properties. They're good materials to producing semiconductors. Their conductivity will change based on the temperature. The 5th group is nonmetals, although halogens and noble gases are also nonmetal, but they have their own groups. These elements in the non-metal groups tend to have a bad conductivity of heat and electricity. They tend to form very brittle stuff. The 5th group is nonmetals. Although halogens and noble gases are also nonmetals, they have their own groups. Elements in non-metal groups tend to have bad conductivity and heat and electricity. They also tend to form very brittle products, which means they are hard but easily broken. Halogens literally mean salt former, and its chemical meaning is also quite similar. Halogens exist in a variety of states at room temperature. For example, fluorine and chlorine are gases. Bromine is a liquid. Iodine and acetane.
One eternity later.
Iodine and acetylene are solids. The transition metals from negative ions are called anions.
So the noble gas is the last group, and they have complete valence electron shell, which is often 8, but 2 for helium. They're the most stable type chemically and don't tend to react with other elements, and they're inert. Noble gases are largely used in industry, for example in arc welding, for filling light bulbs, and so on. So these are basically the 7 types of elements in correspondence with their chemical properties.
It must be very hard and tough to understand and memorize all of them, right? I guess that is for this video, and next week we'll be focusing on how atomic radius, electronegativity, ionization, and energy would affect the compound of elements. See you in the next video. Bruce!